Hi, everyone. We're continuing with lesson 25 on confidence intervals for population parameters. For example, let's say our TA Igor wants to give a confidence interval for the population mean mu of the test scores for a big lecture hall class. And we ask Igor, well, what's your interval estimate for mu? And Igor says, I'm getting an interval between 70 points and 78 points. These here are my limits. And then we can ask Igor, how sure are you? How confident are you that this interval will contain the correct value for mu? It's like answering a big question. How confident are you that this interval will contain the true value for mu? Uh, Again, people like Shrilla don't like saying that mu falls anywhere. Mu is. For example, mu may be right here. Mu could be right here. And the question is, does the confidence interval contain it or not? And we may not know until all the tests are graded. In some applications, we never know what mu is. And when we ask Igor, how sure are you? How confident are you? Typically, Igor will say 95% because that's the standard confidence level for a confidence interval. Remember that a confidence interval is an interval estimate where we attach a confidence level. This is related to the old game show, Who Wants to Be a Millionaire? A phone a friend would be asked, how sure are you that this option is the correct answer? And this was before people just looked up everything on Google for everything. They stopped that phone a friend stuff once they realized everyone was just looking up stuff on Google. Then they went to a 50-50. Anyway, let's go to an applet now. To simulate what I was talking about over here, the idea that if you have a bunch of colleagues who want to know the mean IQ for an American adult, who have 100 different studies and they have 100 different confidence intervals, if they're all 95% confidence intervals and they're all appropriately constructed, then about 95% of them will contain the true value for mu and about 5% won't. Let's demonstrate that. This is the excellent Rossman-Chance applet collection from Cal Poly San Luis Obispo. Chance is named after Beth Chance, who's a professor up there. She's the one who really designed these applets. All right. Now, instead of a confidence interval for a population mean mu, let's do confidence intervals for a population proportion p. For example, a magician's coin. You're given a magician's coin. And you test it out. You want to estimate the probability the coin comes up heads by flipping the coin 100 times. And then based on your sample results, you can develop a confidence interval for P, the true probability that the coin comes up heads. Later on in this course, I'll show you how you can construct such a confidence interval. But this software will do it for us, this applet. All right. Now, actually, this thing's going in reverse. Remember, let's assume that we know the actual value for P. Actually, Professor Rossman preferred using pi instead of P since we use P for so many things. But let's say that the true value for P, the true probability of heads, is 0.5. So that, in fact, the magician's coin is, in fact, a fair coin. So let's assume for now that the coin is, in fact, a fair coin. And let's agree to flip it 100 times. N equals 100. That's the number of trials. Now, the deal is that if X is the number of heads, then in fact, the number of heads will follow a binomial NP, or in this case, N pi distribution. But remember the deal here. The deal is that as we experiment with this coin, we don't know what the true value for P or pi is. The applet knows that's a fair coin. The applet knows that this parameter value is 0.5, but we don't. We're just flipping a coin and we're constructing confidence intervals and seeing what we get. So let's say that we flip this coin 100 times. We don't know that it's fair, but the applet knows the coin is fair. And in fact, it is a fair coin. Okay, well, let's do our sampling. So here's the deal. Okay, so based on this 100 flips, it appears that we are getting 54 heads and 46 tails. So our sample proportion, P hat, I know that's kind of hard to see, P hat. our sample proportion p hat turns out to be 0.540, meaning that out of the 100 flips, we get 54 heads and 46 tails. P hat is 0.540. Therefore, by the way, Q hat, the sample failure probability, is 0.460. We'll use Q hat later on, the sample failure probability. But anyway, this is the result of our random experiment. We flipped this coin 100 times. It was in fact a fair coin, but we didn't know that. We flipped this coin 100 times. We get 54 heads and 46 tails. So our sample proportion p hat is 0.540, or 54%. Now, we don't know it's a fair coin yet. So if this is all the information we have, our best point estimate, our best guess for what p or pi really is 0.540. We've seen the coin come up heads 54% of the time. So our best guess for the true probability of heads, or pi, is going to be 0.540, even though it was in fact 0.5. And then from using methods we'll see later on in this course, here's the confidence interval that can be constructed. Again, using methods we'll see later in this course. So if I click on it, actually, we can see, I'm blowing this up a bit, we can see that this confidence interval is going from 0.442 to 0.638. So we're saying that there is these are 95% confidence intervals, by the way. The confidence level here is 95%. So the claim is that given this sample data, there's a 95% chance, a 0.95 probability, that the true value for p or pi, which we don't know yet, the applet knows it, but not us, we're saying there's a 95% chance, a 0.95 probability, that the true probability of heads on this coin, p or pi, is between 0.442 and 0.638, between about 44% and 64%. Now, it turns out that since this was, in fact, a fair coin, which the applet knows, but we don't, since this was, in fact, a fair coin, this confidence interval is good in the sense that this CI does, in fact, contain the true value for p or pi, the 0.5. It is between 0.442 and 0.638. I'll do some erasing here. But now, what if we try out some other intervals? Let's play around with this applet. Okay, let's try it again. Let's reset this. Let's try it again. Sample. This time we get 46% heads. Here's our CI from 0.362 to 0.558. Again, it contains the 0.5. So it, in fact, turns out to be a good confidence interval. Let's try it again. Okay. Well, we get back to 54% again over here. I don't want to waste your time. All at once, let's do 100 confidence intervals. Let's say that we have 100 people replicating the same experiment. 100 people flipping, I guess one by one. They can't go all at once. One by one, these 100 people flip this magician's coin 100 times apiece. They each get a sample proportion of heads, and then using the same statistical method, which we'll see later, they construct a 95% confidence interval for the true value of p or pi. To keep things fair, it has to be the same confidence level, the same type of confidence interval for all 100 people. So let's do this 100 times. First of all, I should reset this. Okay, 100 times, 100 people replicating this random experiment. What do you think you're going to see? You're going to see 100 confidence intervals. Let's see what happens. Look at that. This, by the way, is the most recent sample, what the 100th person did. That person got 55% heads. We're not so concerned about that. I want to look at the big picture. These are the 100 confidence intervals produced by these 100 people when they flip this coin 100 times. It turned out to be a fair coin. Now, by the way, if you look at each of these confidence intervals, that black dot in the middle indicates the point estimate, the p hat, the sample proportion. So for example, for the very top one, the confidence interval went from 0.452 to 0.648. The point estimate should be right at the midpoint there. Okay. Well, that first confidence interval was good. In fact, Almost all of these are good in the sense that they contain the true value for p or pi, the 0.5. What in fact happened? 96 out of these 195% confidence intervals contained the true value for p or pi, the 0.5. So 96% of these confidence intervals did their job. They contained the true value of p or pi. But 4% of them failed. For example, this guy, this one in red. So for this one, you can see the sample proportion was 0.400, only 40% heads, only 40 heads and 60 tails on this experiment for this person. So the CI was rather low. It only went from 0.304 to 0.496 with 0.4 at the midpoint. But notice here, this falls a bit short. Really blowing it up. Well, you have to blow it up quite a bit, but the 0.496, that falls short of the 0.5. This confidence interval in red will not contain 0.5, the true value for p or pi. So this confidence interval fails. Now, this doesn't necessarily mean that that person didn't know statistics or that the coin was warped by the time the person got it. It may have just been bad luck. It may have just been bad luck that this person just had bad sample results. There were 3 other people in the same position. And once again, for these 95% confidence intervals, notice that 96%, about 95%, contain the true value of p or pi, and about 4% failed. Now remember, it's not perfect. I claim that about 95% of the confidence intervals would contain the true value 0.5, and about 95% did. In fact, here, 96% did. Let's redo this experiment. We can tell the 100 people, hang on, let's do it all again. Let's get another set of 100 confidence intervals. Let's do another sample. This time, for, you could say it's a sample of 100 confidence intervals, only 89% of them contain the true value of p or pi. So we had a much smaller success rate here. Let's try it again. Here, 93% of these CIs contained 0.5. Let's try it again. Let's keep trying it. Whoops. Let's go back to 100. 93%. Let's try it again. 95%. Okay, so this one was really on the dot, but it didn't have to be. 92%. Actually, what if we keep building things up? Let's not reset it. Let's keep increasing the sample size. Well, the sample size of confidence intervals. Okay, so here the running total, 200. 185 out of 200 of the confidence intervals contain the 0.5. So this here, 185 out of 200, that's 92.5%. Let's keep doing this. 100 more people. 100 more people. 100 more people. Look what's happening. Boom, 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 boom. As we keep doing this, notice that our percent so far of these confidence intervals that contain the 0.5, it's getting closer and closer to the 95%. It's like the law of large numbers. By the way, over here, let's reset this. Okay. Looking over here, this here is a histogram of the 100 sample proportions, basically these black dots that are at the midpoints of these confidence intervals. This histogram collects the black dots. And the boxes here in red correspond to the confidence intervals that fail us. Here there were 6 confidence intervals that failed us. We predicted 5 or 5%. You can see here these 6 boxes correspond to the 6 values of p hat that led to these confidence intervals that were too far off. These ones were at the low end, so it's got to be this guy and this guy. These 4 were at the high end, so this guy, this guy, this guy, and this guy. So you might want to play with this applet collection. I'll send the link. All right, so more confidence intervals and interpretations in the next video.